we are going to do a series of videos on exploring the transformations of sine and cosine. So these are our transformational forms, and we're just going to use Desmos to play around with it a little bit. You do not need to take notes. We're going to do formal notes later. This is more just kind of understanding what A does to our graph, what H does, what K does, which we already know those three. It's going to be the same as when we did our absolute value, the same as when we did our quadratic, the same as when we did all of them, rational, all of them. And then B is new. We haven't done B before. So we're going to start with A, then do H, then do K, and then do B. But again, you don't need to take notes here. Just kind of watch, observe, play around with the Desmos. That is linked for you in the assignment. So we're going to start by looking at sine. The reason I'm doing sine and cosine right now and not tangent is because the graph of tangent is different. What happens for sine is going to be the same thing that happens for cosine, and the graphs are so similar that it's pretty easy to see. The graph for tangent is quite a bit different, so we'll do that one separate. The transformations end up being the same, but the graph is different. So for this first one, we're going to be doing changing the value, you can see changing the value of A, and we're going to be looking at all sine. Again, what we do can be applied to cosine. You just would start with a different parent function. Before we start taking a look at our functions, let's just look at our graph. Notice that I've set my domain. It's in degrees. It's in degrees right here. And you will notice that I'm going by 90 degrees. Think about your unit circle. There's 0, there's 90, there's 180, there's 270, there's 360. So those are those quadrantal angles. And then continuing going or going negative. Now the way this will work, to turn a function on, you're just going to click in the circle. So this is our typical sine. And I'm actually going to down arrow so that I can turn on the rest of these things and chat about them. So what I've done here with this table of values, I've gone just from 0 to 360 in the domain. And the reason I picked that out is because that gives me one full cycle. From 0 to 360 gives me one full cycle. I repeat that same shape again and again all the way across my graph, or going backwards, I repeat it. So this here is giving me that one full cycle. Okay? Now our midline right here going through the center is at y equals 0. Remember, the midline is halfway between your max and your min. So my max is 1, my min is -1, halfway between is 0. Which means that my range goes between -1 and 1. So this shading is just my way of showing you these are the values that I have for my range. All of my graph, even going all the way left, all the way right, all of my graph falls between -1 and 1. So for our parent function, our domain is all real numbers, our range is -1 to 1, our period is 360 degrees because I complete one full cycle in that 360, and the amplitude is 1. Remember, amplitude is the distance from the midline to the max and min. So distance from here to here is 1, distance from here to here is 1. Amplitude is always positive, by the way. Okay, I'm going to click a couple of these off and just leave the graph, but I'm going to actually turn that off for just a second. And I'm going to turn on this y equals 2 sine x. So you'll notice in this one the a value is 2. So I've changed from my parent function, the a value is 1, to my transformed function, the a value is 2. And again, I'm going to down arrow. So when I click here, this is still my one complete period. So I went from 0 to 360, and that still gives me one complete cycle. Notice that the difference now, I wanted to leave that on. The difference is now, instead of going from 1 to -1, I'm going 2 to -2. Okay, so this is a vertical stretch. I am taking from the top here and from the bottom here, and I am pulling up and down. So I'm stretching it by a factor of 2. So this has a transformation, a vertical stretch by a factor of 2. This 90, 1 became 90, 2. The 0, 0 stayed 0, 0, because when I multiply 0 by 2, I get 0. 180 comma 0 stayed 180 comma 0. 270 comma negative 1 became 270 comma negative 2. So that's the way that that's working there. Notice my midline stays still y equals 0. But now my range goes negative 2 to 2. So for this function that has a transformation that is a vertical stretch by a factor of 2, all real numbers is still my domain. My range changed. Negative 2 to 2. The period did not. I'm still completing one full cycle in 360 degrees. My amplitude did change. My amplitude is now 2. To go from my center up is 2. To go from my center down to the minimum is also 2. So this changed when I put that 2 there. That changed my max bin. It changed my range. It did not change my domain. It did not change the period. It did change the amplitude. Okay, I'm going to turn these off, and we're going to look at with 3. So hopefully you kind of have an idea of what's going to happen with the 3. This should be a vertical stretch by a factor of 3. And in fact it is. So as I take a look here and compare it, 0, 0 stayed 0, 0. 91 became 93 because I'm multiplying the y by 3. 180, 0 stayed 180, 0. 270, negative 1 became 270, negative 3. And then 360, 0 stayed 360, comma 0. Again, I'm still completing one full cycle in 360 degrees. Right there is one full cycle, 360. 360. So what has changed? My midline did not change, but my domain did. I'm sorry, my range did. So my range, I'm now going from negative 3 to 3. My min is negative 3, my max is 3. So my domain stays the same as my parent function. My range changed, negative 3 to 3. The period did not. The amplitude did. The amplitude changed to 3. Okay, let's take a look at another one. So again, that one was a vertical stretch by a factor of 3. That one was a vertical stretch by a factor of 3. All right, so 1/2. So here's our 1/2, and let's compare it to the sine. So notice this time what happened is it got shrunk. It's like you took something from the top and the bottom and you compressed it. You pushed from the top and the bottom and it brought it down. Again, this is just restricting that domain to 0 to 360. What was 0, 0 stayed 0, 0. 91 became 91/2. That one stayed at 0. 270, negative 1 became 270, negative 1/2. 360, 0 stayed 360, 0. So again, this is a vertical compression by a factor of 1/2. My midline did not change, but my range did. I'm now going from negative 1/2 to 1/2. So my domain did not change, my range did. The period did not change, the amplitude did. From my midline up is 1/2, from my midline down is 1/2. So what changed there was my range and my amplitude. And again, that a value less than 1 is giving us a vertical compression. Now, think about what an a of negative 1 will do. Think about your parabola. It takes it from opening up to opening down. So here is y equals negative 1 sine of x. Again, comparing that to sine of x, it reflected. So what was 0, 0 stayed 0, 0. Because if you're on the x-axis, when you reflect across the x-axis, it doesn't change anything. What was 91 became 90, negative 1. That's 0, 0. 271 became negative 270, negative 1. So this point flipped down here. All the other points flip with it. I'm just using the easy ones to look at. And then the 0, 0 stayed the same. So again, there's my negative sine of x. Here's my sine of x. I reflected it across the x-axis. Same as when we were dealing with our parabolas and our absolute value and every other function we've done. When you have an a value that's negative, it reflects across the x-axis. All right, my midline did not change, still at y equals 0. This case, my domain is the same. I'm sorry, my range is the same as my parent function. I'm flipped, but it didn't change my range. So my domain stayed the same, my range stayed the same, my period stayed the same, and my amplitude stayed the same. Amplitude is always positive. It's from the midline up. It's the distance from the midline to the max and the distance from the midline to the min. So that distance is always positive. Okay? So now, that again was a reflection. So when your A is -1, that's a reflection. So if your A is -2, you've got the negative, so it's going to reflect, and you've got the 2, so it's going to stretch. Okay, again, comparing that to our sine and turning on our values there. There's 0, 0. What was 1 became, oh, I didn't change my values there. 0, 90, 180. I'm just doing my quadrantal angles. Again, I'm only using those particular ones because they're easy. 1, -1, -2, right? So 1, I multiplied by -2, the y value became -2, right? -1, I multiplied, became +2. So this, when your A is a -2, you have a reflection across the x-axis, and you have a vertical stretch. So your midline doesn't change. Still y equals 0. Notice my domain is, I'm sorry, my range, I keep getting those two backwards today. My range is the same as my 2 sine x, but it just got reflected, okay? And then my domain stays the same. The amplitude is 2, because I'm now going up 2. So our last one here, and hopefully you can kind of have an idea of what's happening. -1/2. The negatives should reflect, the 1/2 should compress. So when you have an A value that's negative and not equal to 1, you're going to have two transformations that are happening. Okay, and that already has those turned on, so let's just go ahead and go here. So what was 1 became -1/2, 0 stayed 0. What was -1 became +1/2. So the negative reflects it, the 1/2 compresses it. Midline stays the same. My range changes. I'm going from -1/2 to 1/2. So domain stays the same, the range change, the period stays the same. I'm still going 0 to 360 to complete one complete period. And then the amplitude is now 1/2 from the midline to the max, from the midline to the min. Okay, so that is it for this video where we're changing A. We're going to use cosine in the next video to change your H. And then we'll do a mixture for changing your K. And then we'll do a mixture for changing the B, which will be the only one that is new.